last lab, we discussed the physical and chemical properties of mixtures. In this lab, we will explore the science of meteorology and conduct a weather analysis. As always, before beginning any experiment in the laboratory, be sure you are familiar with laboratory safety requirements. For a demonstration of basic lab safety rules, you can watch our video entitled Lab Safety. Have you ever wished you could change the weather? Even though there is nothing humanly possible we can do to change it, the weather is still a topic of great concern for many people. In the United States alone, more than $5 billion is spent each year trying to predict the weather. Knowing what the weather will be like on any given day will not change the weather, but it can help you prepare for it. For instance, if you knew the skies would be clear tomorrow with a light southerly breeze and warm temperatures, you might plan a picnic and leave your rain boots at home. On the other hand, if you knew tomorrow's weather would include cloudy skies with a cold northerly breeze and scattered rain showers, you would probably plan to wear a coat and take an umbrella with you. The science of predicting the possible weather conditions for a particular period of time is called weather forecasting. Accurate weather forecasting is crucial to aircraft pilots, ship captains, farmers, construction workers, and many other people whose livelihood depends on the weather. Weather forecasting helps us prepare for severe weather conditions, such as thunderstorms, hurricanes, tornadoes, or blizzards. Weather forecasting is one of the responsibilities of a meteorologist. A meteorologist is one who studies Earth's atmosphere and weather. What data do meteorologists use to make weather forecasts, and how do they obtain that information? Meteorologists use weather-related data from satellites and from the International Space Station orbiting Earth. They also gather weather data from numerous pulse Doppler radar installations. Pulse Doppler radar uses microwaves to determine the speed and direction of raindrops in clouds. Doppler radar is especially helpful in predicting the path of severe storms and tornadoes. However, most of the weather data used by meteorologists comes from weather stations. A weather station is a facility with instruments for measuring atmospheric conditions. Weather stations include global weather stations from all parts of the world, local weather stations, and amateur weather stations similar to the one we will be using in this lab. Like the larger weather stations, our station has a thermometer to measure temperature, a hygrometer to measure humidity, an anemometer to measure wind speed, a rain gauge to measure precipitation, and a wind vane to determine wind direction. Data recorded by the instruments in our weather station are transmitted through an antenna to the console of our base station. Weather information is displayed on a digital display on the weather console. Our weather station also includes a barometer to measure atmospheric pressure, but the barometer is located inside the base console. Atmospheric pressure measured by a barometer is called barometric pressure. A meteorologist uses these atmospheric factors: temperature, barometric pressure, wind speed, wind direction, and relative humidity to forecast the weather. However, to provide an accurate forecast, the meteorologist must be able to observe these factors both locally and in other regions. Since our atmosphere surrounds Earth, air in one region of Earth is connected to air in all the other regions, either directly or indirectly. As a result, changes to the atmosphere in one region produce changes in other regions. For instance, the barometric pressure in one region affects its neighboring regions. Suppose you live in a region where the air near the ground is warm. A friend lives in a neighboring region where the air near the ground is cool. The atmosphere in both regions contains molecules of air. Molecules are in constant motion, so they frequently collide with each other. The collision of air molecules produces barometric pressure. In your region, the sun's rays heat the air, which causes air molecules to move faster and farther apart. Since they are farther apart, they collide less frequently, which produces a pocket of low barometric pressure in your region. In your friend's region, the air is cooler, so the molecules of air move slower and remain closer together. Since the molecules are closer together, they collide more frequently, which produces a pocket of high barometric pressure in the region. Air moves from regions of high barometric pressure into regions with low barometric pressure. This moving of air is called wind. So, what causes wind to blow continually for several hours or even days? Continual winds occur because of the wind cycle that begins when warm air in your region rises higher into the atmosphere and cools. When the air cools, the molecules pull closer together. Collisions between molecules become more frequent, and the barometric pressure increases. At the same time, warmer air in the upper atmosphere of your friend's region produces a pocket of low barometric pressure above the pocket of high pressure. Air moves from the pocket of high barometric pressure in the upper atmosphere of your region toward the pocket of low atmospheric pressure in the upper atmosphere of your friend's region. This produces wind in the upper atmosphere. The warm air in the upper atmosphere over your friend's region cools and descends. When the air cools, its barometric pressure increases and produces a pocket of high barometric pressure near the ground. This new pocket of high barometric pressure in your friend's region completes a wind cycle that produces a continual flow of air between the two regions. If there is only a slight difference in barometric pressure between two regions, the wind will be mild or slightly breezy. If the difference in barometric pressure is great, the wind will be strong and blustery. An extreme difference in barometric pressure could produce gale force winds. Regions of high or low barometric pressure are indicated on a weather map similar to this one. A region of high or low barometric pressure, compared to the air around it, is called a pressure system. Another important factor that affects weather is humidity, which is the amount of water vapor in the air. However, meteorologists are more concerned with relative humidity and with the dew point. Relative humidity is the actual humidity compared with the total amount of water vapor that air can contain at a specific temperature. For example, if the relative humidity is 56%, the air contains 56% of the total amount of water vapor it could contain at that temperature. Dew point is the temperature at which air becomes saturated with water vapor. At the dew point, the relative humidity is 100%. If the temperature of air with 100% relative humidity falls below the dew point, water vapor in the air will condense to produce precipitation in the form of dew, rain, snow, or frost. Cooler air with a higher barometric pressure cannot contain as much water vapor as warm air with a low pressure. Cool air with a higher barometric pressure usually indicates that the skies will be clear with little or no precipitation. But warm air with a lower barometric pressure usually indicates that skies will be cloudy with a chance of precipitation. Now that we understand some of the factors that affect weather, let's put our knowledge to work with a weather analysis. For this lab, you will need to record your observations on a weather analysis chart similar to this one. You will be making observations of the current wind direction, wind speed, outside temperature, relative humidity, barometric pressure, and daily rainfall from our base station. Then you will use that data to record the day's weather. To know how to identify the data shown on the display screen of the base station, look at this sample. The first measurement we will examine is wind direction. Wind direction can tell us if a pressure system is heading toward us or away from us. Notice, there is one solid arrow and 3 open arrows in the wind direction compass. The solid arrow is the current wind direction, which we will be recording on the weather analysis chart. The open arrows indicate changes in wind direction over the past hour. The 8 possible wind directions correspond to the points on a compass: north, northeast, east, southeast, south, southwest, west, and northwest. Each direction refers to the direction from which the wind is blowing. So, if the wind direction indicator reads southwest, that means that wind is blowing from the southwest. Notice that the solid arrow for the current wind direction is pointing to a spot between 2 points on the compass. When the arrow points between 2 points on the compass, we include both directions. The major direction, north, south, east, or west, closest to the arrow is listed first. In this case, the current wind direction would be read as west-northwest. Record the current wind direction on your weather analysis chart for the day marked S for sample. Wind speed is recorded inside the circle of the wind direction compass. Wind speed is measured in meters per second. The sample display shows a wind speed of 1.8 meters per second, just a slight breeze. Our weather station can detect even the slightest of breezes, but a wind speed less than 1.8 meters per second would not be felt by a person, so it would not be considered windy. Record the wind speed on your weather analysis chart. The next reading is the outside temperature. The outside temperature is 20 degrees Celsius, which is almost the same as the room temperature. Record the outside temperature on your weather analysis chart. Relative humidity is our next reading. The relative humidity today is 65%. Whenever the relative humidity is above 60%, there is a good chance of precipitation that day or the following day. Record the relative humidity on your weather analysis chart. Next, we will look at the barometric pressure. The barometric pressure is measured in millibars. The reading on our base unit is 1011.4 millibars. According to a National Weather Service, the average barometric pressure for this month is 1015.9 millibars, so our pressure is slightly low. Notice the arrow to the right of the word barometer on the display. This arrow tells us the barometric trend. The barometric trend is a comparison of the current barometric pressure with the previous pressure to tell us how the pressure has changed since the previous reading. The angle of the barometric trend arrow tells us if the barometric pressure has risen greatly, risen slightly, if there has been no change, or if the pressure has fallen slightly or fallen greatly from a previous reading. With the barometric trend, a meteorologist can tell at a glance how the barometric pressure is changing. The barometric trend in our sample display tells us that the barometric pressure has risen slightly since the previous reading. Record the barometric pressure and the abbreviation for the barometric trend on your weather analysis chart. A change in barometric pressure indicates that a change in the weather is coming. If the pressure is falling, precipitation is on the way, and we should expect overcast skies with some precipitation. If the pressure is not changing, you can expect the weather to remain the same as it is currently. If the pressure is rising, the weather is clearing, and we should expect clear skies soon. Our final reading is daily rainfall, which is the amount of rain that has fallen since midnight the previous night. Daily rainfall is measured in millimeters. We see that no rain has fallen today. Record the daily rainfall on your weather analysis chart. Based on our weather observations, what weather can we expect for today? With warm temperatures, a slight breeze, moderately high relative humidity, low, slightly rising barometric pressure, and no rainfall, it should be safe to forecast a warm, sunny day with clear skies and no rainfall. Mark your forecast in your weather analysis chart. Now it is time for you to be a meteorologist. We have recorded atmospheric data for 5 days. Record the data and current conditions for each day. Here is the display screen on the base station for day 1. Record this data on your weather analysis chart. Here is the display screen on the base station for day 2. Record this data on your weather analysis chart. Here is the display screen on the base station for day 3. Record this data on your weather analysis chart. Here is the display screen on the base station for day 4. Record this data on your weather analysis chart. Here is the display screen on the base station for day 5. Record this data on your weather analysis chart. Weather forecasting is a bit more complicated than simply reading weather data for a week. But this gives you some idea of what a meteorologist must do to provide an accurate forecast. In our next lab, we will examine some of the physical laws that explain the behavior of gases, such as those that make up our atmosphere. At this time, proceed with the corresponding activities.